Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the change in enthalpy of reaction as well as the change in internal energy of reaction at 298 Kelvin for the reaction carbon in basically graphite plus H2O gas react to form carbon monoxide plus H2 gas. So to solve this question, we have to first of all write out this particular equation or formula which says the change in enthalpy of reaction is going to equal the sum of basically this. Hold on, I'm just going to write it out and I'm going to explain the formula for you. So you would observe that this equation is just you repeating this and this. So basically, I'm writing that two times, but there is no problem with this equation. It's just that the first part is when you're dealing with products, and the second part is when you're dealing with reactants. So what this particular formula is just telling you that when you're trying to determine the change in enthalpy of reaction, you're going to first of all sum up the change in enthalpy of formation for the products, and when you do that, you're going to sum them all up or just basically add them up. And whatever value you get will be minus the sum of the change in enthalpy of formation for the reactants. So we're going to use this question in order for you to get the question properly. So first of all, you have this formula now. So I'm going to write it out as we applied to answering this question. So I'm going to put it down. See, change in enthalpy of reaction is going to equal the product. So we're going to just first of all say the enthalpy of formation, okay, for enthalpy, okay, I'm going to bracket it of CO gas plus, so don't forget we're summing it up, the change in enthalpy of formation for H2 gas, okay, a lot of information, we add them up, and then that minus the change in change in enthalpy of formation, which is right here. So that will be change in enthalpy of formation for carbon graphite. Okay. Plus, don't forget we have the summation for a reason. Change in enthalpy of formation for the H2O gas molecule. Now, make sure you pay attention to everything that you're giving. Make sure you pay attention for the phase of the reaction, because this particular case now we're seeing that we're dealing with H2O gas. A question can come when you're dealing with H2O liquid. So just pay attention there, because there are some times whenever a molecule can take both the liquid phase or the gas phase, or sometimes when the solid phase, the value would differ based on all these phases. So make sure you pay attention to the phase that the reaction occurs. So you can see that I've written all of this out. I'm just basically writing it out little by little. So before we go on to solve this question, I want to put some information that will be very useful to you. Some of you may not have the resource section of your book, or the part of your book that of the Atkins physical chemistry book that would show the different change in enthalpy of formation for different molecules that we're going to be studying in the book. So in case you don't have the Atkins book, you can just type the change in enthalpy of formation for carbon monoxide gas on Google. That will give you what you need. So in this particular question, I'm just going to give you all of them, and then we're going to use that information to basically solve the question. So yeah, that's very, very important. That's basically the information. So of course, we're going to just simply substitute. Okay. So we're going to substitute one by one, one by one, one by one. So changing enthalpy of the reaction is just simply going to be this one here. The carbon monoxide is just, we're going to substitute it. So that will be negative 110.53 kilojoule per mole. Okay. Plus 0. Okay. Minus change in enthalpy for carbon graphite is going to be 0. Okay. Plus, we're dealing with formation. We're on this one here now. We're on the last one. So that's going to be changing enthalpy of formation for H2O gas. So that's going to be plus negative. Well, let me use red pen so we're consistent. That's going to be negative 241, okay, 0.82 kilojoule per mole. So that's basically what's going on. So we move on. So changing enthalpy of reaction is going to be negative 110.53 kilojoule per mole Okay, minus and then plus minus. So that will be minus plus minus is just going to give you a big plus, and then that will be 241.82 kilojoule per mole. So having this information, we have change in enthalpy of reaction to now equal 241.82 minus 110.53. So that's going to give you 131.29 kilojoule per mole. Okay, so that's basically the answer to this question. So yeah, that's how you solve it. No issue, super easy, super duper easy peasy. So going back to the question, we've seen that we've been able to successfully answer one question: change in enthalpy of reaction. Now we have to know the change in enthalpy. Sorry, now we have to know the change in internal energy of reaction. So now we're supposed to solve for this change in internal energy of reaction. Now the first thing you have to note is this formula I'm about to write is what you need anytime you're giving maybe enthalpy and change in enthalpy of reaction, but you're not giving the change in enthalpy, sorry, change in internal energy of reaction. Basically, when you know the value of one, you're going to know the other value. Just you making sure to use this particular equation. So the equation is change in enthalpy of reaction minus change in internal energy of reaction equals N, change in Ng, RT, where change in Ng is simply the change in the number of gas molecules. Of gas molecules. So that's basically what's going on here. So I'm going to first of all rewrite the equation down here so nobody needs to go back. I don't need to go back up and no one gets confused. So just rewriting the equation plus, I promise you this is important for me to write. So that's going to be CO gas plus H2 gas. Okay, so now we already know this part of the question, right? We already know this value because we just solved for it. We're trying to find change in internal energy of reaction, and we need to now know this value. By the way, temperature is what T is, and R is basically gas constant. Okay, gas constant. Now you're going to be wondering what is change in Ng or change in number of gas molecules. Well, it's just going to be the number of gas molecules at the final state minus the number of gas molecules at the initial state. So that is basically what this is showing you. So that's going to be number of gas molecules for the final state minus number of gas molecules for the initial state. So for the final state, you see, going back to our equation, this is the reason why I was writing the equation in the first place. We have one gas molecule for CO and then one gas molecule for H2 gas. So we have two gas molecules here. That's finally after the reaction is taking place. Now, for the reactant, before the initial reaction occurs, we have just one H2O gas molecule. So 2 minus 1 is 1. So this answer is 1. So basically, changing number of gas molecules times R times T is equal to 1 times 8.3145 joule per mole Kelvin times 298 kelvins, right? So change in, so basically this information here equals, going back to our work, of course, we can cancel out kelvins. So 8.3145 times 298 will give you 2477.72 joule per mole. Sorry, I was about to write kilojoule, just joule per mole for this question. So yeah, it's basically the answer. Now, of course, because our question is to find the change in internal energy of the reaction, and we have this, we just have to rewrite the formula. So rewriting the formula, we have so having this information, we have changing enthalpy of reaction to be 131.29 kilojoule per mole, and then change in NGRT. Well, in this particular case, we have our information in joules per mole. So going from kilojoules, from joules per mole to kilojoules per mole, will just involve us dividing by 1000. And if we do that mentally, basically in our brain, we get 2.4772 kilojoule per mole, okay, equals change in internal energy of reaction. You can see how simple this question is. It's just going to take a little bit of time and then you're done. Super, super, super done. So change in internal energy of reaction equals 128.8123 kilojoule per mole. Of course, this question we can approximate. So I'm going to be doing this approximation in terms of two decimal places or four sig figs. I can do both. So in terms of two decimal places, we would end up with 128.81 kilojoule per mole. So this is in two decimal places. And if we're to do this in three sig figs, we're going to have change in internal energy of reaction to be 129 kilojoule per mole. So this is in three significant figures. So yeah, that's basically the end of this question. I wish you guys all the very best. If you have any questions, please put it in the comment section. I am here to help you as well as to assist you. So for anyone who would want personalized tutoring outside of YouTube videos, I'm a tutor who helps students who want to succeed in their academic life and in their future career in order for them to be the best version of themselves as well as succeed in academia. So if you'd want my services for STEM related courses as well as mentorship while you're in middle school, high school, or college level, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Put your comments in the comment section, your concerns and your suggestions. Assalamu alaikum wa rahmatullahi wa barakatuh.